Okay, so as we look at this section, we're talking about the last way we have that we're factoring. It's called factoring by grouping. And what it basically does is it takes us into a situation where we no longer have a binomial or trinomial that we're comfortable factoring. We actually here in these cases have four terms. So here's how this works. What you ultimately end up doing is you, number one, need to always look for GCF, right? Always look for a GCF. We've talked about that from the very beginning. As you look at this, though, in these four terms, there is no exact GCF for all four of them. However, what we do have is, and we're trying to get in grouping, is we look individually at two groups. So I'm looking at both of these groupings of underlined in blue. They're both binomials. The first binomial is GCF. I'm going to take out. That's x squared. So I'm writing down x squared, and I'm left with x plus 3. Now, here's my goal. Once I establish that, I'm playing a matching game. I want whatever I'm left with over here in parentheses, I want it to match with x plus 3. So I'm trying to match and get x plus 3. And as soon as I decide that or recognize that, that will dictate what my GCF is. So in this case, the GCF would be 2. I'm not going to just write 2, but it's a positive 2 that I need to take out to create x plus 3. Now, once I do that, I'm basically at the end. Now what I do is, when I write this down, is one of my binomials will be the match, which is x plus 3. So that comes from here and here. The other one will be what precedes the matches. So that will be x squared. That will be the x squared, and that will be the plus 2. So there's my final answer. And again, just want to double check that this binomial has no GCF. So that's how I know it's done. And it's not a perfect squared binomial because 2 is not perfect. Now, as I look at the second one, same situation. Sometimes, though, you do need to rearrange. But in this case here, as I look at this group, and this group, it looks like they both have GCF. So I probably can get a match. First GCF under the first grouping is going to be m squared. I'm going to take it out. I'm left with m plus 7. So that means I need an m plus 7 from that binomial. But to make that be an m plus 7, that means I need to take out a negative 2. So I take out a negative 2, then I'm left with an m plus 7. So you may have to adjust your signs of what you're GCFing in order to generate the match. So I got a match of m plus 7. And then what precedes it is an m squared and a minus 2. Again, just double check. That is not perfect square binomial because the 2 is not perfect. So that is my final answer. Letter C here, you will need to make sure you rearrange. It was a misprint in the notes. So if you notice as things exist right now, these guys don't, as they're situated, they do not have a GCF. That first grouping of 2 has no GCF. So I need to rearrange that. So what I'm going to do is I will go ahead and rearrange and put things together that look like they can be. So I'm going to put the n cubed and the plus 6n squared next to each other. And then I'll put the 5n and the 30 next to each other. Because as I look at this, those guys have a GCF and now these guys do. So you may need to rearrange. That's why this one's a little bit different. GCF is going to be n squared here. I'm going to take out an n squared. I'd be left with an n plus 6. And again, I need that match to occur from the second grouping. So to get an n plus 6, I would GCF out a positive 5. And I'm left with an n plus 6. So my final answer would be n squared plus 5 times n plus 6. Final answer. Okay, same things occur here. In this next D, E, and F, what you're going to have to do is rearrange, though. So I would probably go x squared plus x xy plus y. This way, I have a GCF of x in that group, and in this group, I have a GCF of y. I'll take out an x. I'm left with an x plus 1. And to get an x plus 1 from the second group here, I would then take out a positive y, and I'd be left with x plus 1. So my final answer, x plus y times x plus 1. This guy again here in letter E, it will need to be rearranged. So I'm gonna, again, you can ponder and work through it potentially in different fashion, but ultimately your binomials need to be what I have there. So I would rearrange this as a cubed plus a plus 3a squared plus 3. So I would GCF out a, I'm left with a squared plus 1. So I need a match over here of a squared plus 1 in this group. So I would take out a 3, positive 3 that is, and I'm left with an a squared plus 1. Final answer, a plus 3, a squared plus 1. Moving into letter F, again, you're going to have to rearrange. I went ahead and rearranged as y squared plus yx plus 2x plus 2y. Taking out a y, I'm left with y squared. I'm sorry, excuse me. Taking out a y, I'm left with y plus x. And to get that over here, I would take out a 2, and I'm left with an x plus y or a y plus x. That doesn't matter that these come out to be different because of commutativity. So I can just go ahead and match them up as I rewrite them. So again, we'll go by the alphabet. X plus y and y plus x are the same thing. There's your final answer. Okay. This last section here, as we look into it, we are talking about making sure we're factoring completely now. So as we factor completely, we have to consider doing multiple levels of factoring. So the first thing we do is we're going to locate or write down the fact that the GCF is 3x. Writing down that, we would have x squared plus 2x minus 6. So what we want to do now is we want to test this out right here to see if it can be factored. So it's a trinomial, it's not perfect. So we would test AC plus B, but as we did that, you're going to notice that there's no combination that would work in those two spots to generate a multiplication of -6 and addition of 2. So this ends up being your final answer. Not all the case, but it is the case here. In letter B, I would take out 7x squared as my GCF, and I'm left with x squared minus 4. Now, that's interesting because that is a perfect squared binomial. It's a binomial. Both values are perfect, the x squared and the 4, and there's a minus sign. So if you recall from past lessons, that would be factored into x plus 2x minus 2. So again, just multiple levels of factoring. And lastly, I would GCF out of 3x to start, and I'd be left with x squared minus 4. Similar scenario over here. That just turns into x plus 2 times x minus 2. Final answer. And we would do the same exact things here. If you'd like to work through them, I'll just write down the final answers for them. You would have 2y and then y minus 3 squared. GCF of an m. And then it looks like you probably have to AC bus B here. Final answer, and here, this would be 2x minus 7, and then 5x squared minus 3. So this basically took us through our first day of factoring with grouping and completely. So I'm going to stop here, and I'll post a second video to finish out the lesson. That will be our second day of the lesson.